Hello, I'm Nigel Deakin, and I work for Oracle, where I'm the specification lead for JMS 2.0. JMS stands for Java Message Service, which is the Java standard for enterprise messaging, and I'm here to tell you about some of the changes that have been introduced into this new version. JMS is one of the core technologies of Java EE, but it can be used on its own in applications which don't use Java EE at all. JMS is a technology that allows developers to send pieces of data, what we call messages, between different server programs in a very decoupled manner. These pieces of data can be stock prices, orders, almost anything that one part of an organization might want to send to another. JMS allows these different systems to be decoupled physically, so they don't need to know who they're sending messages to or who they're receiving messages from. JMS also allows the different systems to be decoupled in time, so one system can send a message at one time, which another system can pick up and process at a later time. All this together means that JMS is a really useful technology for connecting disparate systems in a larger IT infrastructure. JMS 2.0 is the first update to JMS since version 1.1 almost 10 years ago. I think one of the reasons why JMS hasn't been updated for such a long time is that the original authors got it pretty well right, and that people have been able to just get on and use it. There are a wide variety of competing implementations from a wide variety of organizations, large and small, closed and open source, which are being actively developed and used. However, the fact it hasn't been updated for such a long time does mean that it's rather missed out on some of the improvements that have been made to other Java APIs to make them easy to use. And that's why the main goal of JMS 2.0 has been to make it easy for developers to use, and in particular to exploit some Java technologies such as annotations and dependency injection, which weren't around when JMS was last updated. We've achieved this by creating a completely new API, as well as by making some incremental improvements to the existing API. And in addition to being easy to use, JMS 2.0 also contains a small number of new messaging features which have been added in response to community requests. I'm now going to take you through some of the new features of JMS 2.0. I'm going to tell you about a completely new API that we've added to make JMS easy to use. I'm also going to tell you about a few specific simplifications we've added. I'd also like to mention some features we've added that will make it easy to use JMS in a Java EE application in particular. And finally, I'll run you through a few new messaging-related features. So let's go through the main new features of JMS 2.0 in a little more detail. The biggest new feature is a new API, which we're calling the simplified API, to reflect its main purpose of being simpler and easier to use, and so making developers more productive. The simplified API is intended to offer a complete replacement to the existing API, which we'll now be referring to as the classic API. The simplified API is simpler because it requires you to manage fewer objects, and in general, it just requires you to write less code. And in particular, it reduces the amount of boilerplate code that's essentially the same in any application that uses JMS. However, I want to just make clear that if you want to continue using the classic API, as we're now calling it, well, it's not going away, and in fact, we've made a number of improvements in this as well to make it simpler. It's time to look at some code. Here's an example of the kind of code that you need to write currently in JMS 1.1 if you want to send a message to a queue. In a moment, I'll show you how you can use this using JMS 2.0. But in JMS 1.1, in the classic API, you start with a connection factory, you create a connection, you create a session, passing in those two parameters, then you create a message producer, and then you create a text message and set the body of the text message to the text string that you want to send. Having done all that, you can at last send the message. But finally, before you finish, you need to remember to close the connection. The thing I want you to see here is there's a lot of boilerplate code just to send a message. So let's now look at how you might do the same thing in JMS 2.0 using the new simplified API. And here it is. It's quite a lot simpler. Again, you start with the connection factory. This time you use it to create a JMS context object. Now this is a new object. It's the main object of the simplified API. From the JMS context, we need to create a producer, and from that we send the message. So here, I just want you to see the obvious. There's much less code here. So just a couple of things. Note that we haven't actually created a message object in this example. We've simply passed the text string direct to the send message. The other thing I want you to note is that we haven't actually called close at the end, and that's because we don't need to. Having seen this example, we'll now look at some of the key components of the simplified API. So the first thing to say about the simplified API is that it's designed to reduce the number of objects that your application has to manage. The big change is that whereas in the classic API you always had to create a connection and a session, in the simplified API, these two objects are replaced by just one, a JMS context, which offers all the features of both. Another change is the parameters you need to supply when doing this. In JMS 1.1, when you created a session, you had to supply two parameters, the transacted flag and the acknowledgement mode. You don't actually need two parameters here, so in JMS 2.0, you can supply the same information using a single parameter. This applies to both the simplified API, when you're creating a context, and to the classic API, when you're creating a session. And there's also a version with no parameters at all. In this case, you'll get a defined default behavior. In Java SE, the default is non-transacted with auto-acknowledgement, whereas in a Java E transaction, the default is to use that transaction. Now, keep in mind that if you use any of these methods in a Java E transaction, any parameters are going to be ignored anyway, since you'll always use the Java E transaction. So therefore, the fact that we've now got a method with no parameters, it means you no longer have to supply in your code information or parameters that you know will be ignored. So in addition to reducing the amount of code you have to write, this actually just makes your code more clear and less confusing. Now let's look at a third big new feature of JMS 2.0. At the top, we have an example from JMS 1.1 in which we create a connection. Then we do something with it, and then we close it afterwards. Since we always need to close the connection, even if we get an exception, we put the close in a finally block. Now below it, we've got the JMS 2.0 equivalent. We're using the simplified API here, so we create a JMS context. But the same would apply if we were using an ordinary JMS connection. Now the key thing to note here is that we're not calling close at the end. And that's because we're using a special syntax, which was added in Java SE 7, called a try with resources block. If you use this syntax when you're creating a JMS context or a connection, then you don't need to call close after use. It'll get called automatically for you when you get to the end of the block. Now, the use of try with resources also simplifies exception handling, though we won't go into that here. The fourth big new feature of the simplified API is that when you're sending a message, in most cases, your code doesn't actually need to create a message object. Instead, you can simply pass the message body, a string in this case, into the send method, and JMS will create the message for you. There's one other feature we should look at here. This is the new producer object in the simplified API. Whereas in the classic API, you send a message using a message producer object, in the simplified API, you use a JMS producer object. Now, this is designed so you never need to save it in a variable. You should always be able to create it in the same line as the send method, as shown here. I'll say a little bit more about this later, but essentially this is another way in which you use less code. That's enough about sending a message. Now let's look at the code you need to write to receive a message. In this case, a text message. Okay, here's an example from JMS 1.1 of the code you need to write to receive a message synchronously. By synchronously, we call the receive method, which blocks until the message is actually returned to the code. So you start with a connection factory and use it to create a connection. Then you use the connection to create a session. And then you use the session to create a message producer. You then call connection.start, which starts delivery of messages to the connection. You can now call messageConsumer.receive to receive the message. When you've got the message, you then cast it to a text message, and then call the getTextMessage to extract the text. And then finally, we close the connection. Now let's look at how you do the same thing using the JMS 2.0 simplified API. As you can see, there's a lot less code. Now, much of the saving in code here is the same as when sending a message. Instead of separate connection and session objects, we've got a single JMS context object. We don't need to pass unnecessary parameters when creating it. And if we do this in a try with resources block, we don't need to call close after use. But let's look at some aspects particular to receiving a message. In the classic API, if you want to receive a message, you need to create a message consumer object, and then call connection.start to start delivery of messages to the connection. In the simplified API, you need to create a JMS consumer object. Now, this is quite similar to the message consumer object, but the difference is that you don't need to call start. The delivery of messages will begin automatically. That saves you one line of code every time. If you don't want delivery of messages to start automatically like this, you don't have to. You can turn it off. The other new feature of the simplified API is the ability to receive a message body directly. By message body, I mean the message payload, such as the string of a text message or the bytes of a bytes message. Now, currently, what you have to do is to receive the message object, then you cast it to the appropriate subtype, such as text message or bytes message. And then you have to call the appropriate method to actually extract the message body from the message. In this case, it was getText. Now, in the simplified API, instead of calling the receive method, which returns a message object, you can call the receive body method, passing in the expected body type. JMS will then receive the next message, extract the message body, and return it to you. So this saves you a line of code and also avoids the need to perform a cast. So far, we've looked at how JMS 2.0, and in particular the new simplified API, simplifies the amount of code you need to write to send and receive JMS messages. These benefits are available to all types of JMS application, whether you're running in a standalone Java SE application or in a Java EE application server. But if you're running in an app server, there are some extra features which make using JMS even simpler. The first is that you can inject JMS context objects directly into your code. So here's an example of some code that you might write in a session bean or a servlet to send a message. This uses a JMS context to create a producer and send the message body directly. But you'll see that there's no code to create the JMS context. Instead, we simply declare a field of type JMS context and add a couple of annotations. If we do this, the app server will create the JMS context for us. And when we finish, the app server will close it. The main annotation you need to add is @inject, which tells the container that you want it to create the JMS context for you and close it after use. Now, you can also specify the connection factory you want it to use using the @JMS connection factory annotation. Now, I think this is a really powerful feature. Combined with the other features of the simplified API, it reduces the amount of code you need to write, particularly to send a message, to almost nothing. Now, let's talk a bit more about connection factories. If you're using JMS, you always need a connection factory. And in Java EE, that means configuring it in JNDI somewhere and then looking it up from your application. Now, Java E7 makes this easier. It provides a built-in connection factory which your application can look up and use to connect to the app server's built-in JMS provider. And in a lot of cases, that's all you need. If you're injecting a JMS context, then by default, it'll use the default connection factory. So just declare the JMS context in a field, add the @inject annotation, and you're done. You can use it to send and receive messages. If you're not injecting a JMS context, but want to use the @resource annotation to inject the connection factory itself, then you can do that by specifying this special string as the lookup name. Now, the default connection factory won't always meet your needs. Sometimes you'll need to configure something more specific, and you'll always need to configure the queue or topic resource that your application requires. Now, in the past, you had to do this using admin tools specific to your app server. But with JMS 2.0, you can simply add annotations to your code that define the connection factory, queue, and topic objects that your application requires, and the application server will create them for you. This brings us to the end of the summary of the new features that make JMS easy to use in all types of application, but particularly in Java EE application. But before we finish, I'd just like to mention 4 of the new messaging features which we've added to JMS 2.0 in response to community requests. The first new messaging feature is provided for applications which consume messages from a topic and is particularly aimed at those which run in the Java SE environment rather than in an app server. As you may know, messages from a topic are consumed via a subscription, which receives a copy of every message sent to the topic. Now, the problem in JMS 1.1 was that a subscription on a topic could have only one consumer at a time. This meant that a Java SE application couldn't share the work of processing messages from a topic subscription between multiple threads, multiple JVMs, and multiple machines in a way that a Java EE application that uses a message-driven bean can. So this limited the scalability of such an application. Now, in JMS 2.0, this restriction has been removed. You can now create a new type of topic subscription, which is called a shared subscription. These can be either durable or non-durable and can have any number of consumers. The next new messaging feature I'd like to mention is delivery delay. This is quite a simple feature, which a number of existing JMS providers already offer, albeit in a non-standard way. Before you send a message, you can set a delivery delay in milliseconds. After you send the message, the JMS provider won't deliver it to consumers until after that specified delivery delay has elapsed. Delivery delay is available in both the classic API and the simplified API via a new method called setDeliveryDelay, depending on which API you're using, the message producer object or the JMS producer object. While we're looking at this, I'd like to mention the detail of the second example here. You'll see that the call to setDeliveryDelay has been inserted into the same line of code that calls send. This is because calling setDeliveryDelay on JMS Producer returns the JMS Producer object itself. The JMS Producer object, in fact, is expressly designed to allow you to chain methods like this. We sometimes call this the builder pattern. This allows you to keep your code compact and avoid the need to declare a JMS Producer variable in your code. The next new feature has been added to make it easier for applications to handle messages which are bad in some way and which your application code can't handle. An example of this is an application which uses a message listener to consume messages from a queue. When a message is delivered, the onMessage method is called to allow the application to process the message. However, consider what happens if there's a problem with the processing of the message. Perhaps the data in the message is invalid for some reason, and the application doesn't know how to handle it. If this happens, it's probable that an onMessage will throw an exception. However, this will cause the server to deliver the message a second time. If the same problem occurs, then you'll get an exception again, and the message will deliver the third time, and so on. How do you break this endless loop? Well, in JMS 2.0, every message that's delivered now contains a predefined message property called JMSX delivery count. This is set to the number of times the message has been delivered. So the application can check this value and use it to detect that the same message has been redelivered, say, 10 times. It can then take action to break the loop, such as consuming the message and logging an error, or possibly diverting it to some other queue, processing separately. Well, JMS 2.0 is the first update to JMS in a decade. Now, the main focus of this update has been to make JMS more productive for developers. With this new API, JMS 2.0 is simpler and easier to use, with fewer objects to manage, simpler methods to call, and less code to write, and with much less of the boilerplate code that seems to be the same in every application. All in all, making developers that use it more productive. In addition, a number of new messaging features have been added, which address some practical, real-world issues when writing JMS applications. So, thank you for learning about JMS 2.0. You can find out more about JMS 2.0 at the JMS specification website, jms-spec.java.net. You can get JMS 2.0 right now in GlassFish 4, the Java E7 SDK. Please download it and try it out. To find out more about this and other Java E7 technologies, follow us on Twitter, join us on Facebook, watch us on YouTube, and read all about Java E7 on the Aquarium blog and at glassfish.org. Thank you.